Hey there. Okay, now we're going to do some cleanup and make our library a little bit nicer. And just, I said I would remind you that I'm at Joel Grus. So last time we were on part 03, so let's make sure we're clean. So let's make a new branch, part 04, and check it out. Okay, good. So I have all these in the wrong order. Good. So what do I want to do here? I want to clean everything up and fix something stupid that I really did. So what do I mean by clean everything up? I mean that, when we went through this minimize function, it was a real nuisance to have to call the mul function. I'd like to just be able to say x times x, and same when I want to multiply this gradient by 0.1, I had to wrap it in a tensor, and I had to call the mul function. And so, if you don't know, Python has these double underscore methods like repr that it can use to do things, right? So, for instance, I can do neg of, I won't do neg, I'll do add self and other, and that will give me a tensor. And other can be anything, right? This is what gets called, gets called if I do t plus other. And so other could be a tensor, but it could not be a tensor. And there's some cases where you only want to allow to add the same things. Here, though, you'd like to be able to add a tensor and a scalar or a numpy array or anything. And so one way we can do that is just as we had this ensure array, we can do the same thing. Tensorable equals, so what is allowed to be added to a tensor, if you will. So a tensor, obviously, and a float, and I actually don't want to do a list, but I'll let you get away with a numpy array. And let's say ensure tensor, tensorable. I hope you like these names that I made up, which is a tensor. So if the thing you gave me is a tensor, then just return it. Don't do anything to it. Otherwise, I just want to return the tensor of tensorable. So, if it's float, that's okay to pass into tensor, and if it's a numpy array, that's okay to pass into tensor as well. Okay, and so I just want to return add self and ensure tensor other. And then I actually want to do one more thing, which is I want to make this add function kind of private. So I could move it to another module, but that would make my life complicated, so I'm just going to leave it here and add an underscore so that it doesn't tell you make things private in Python. And then I'm also going to do this radd, which could be confusing. So what is radd? So this gets called if I do, other plus t. So if I do like 3 plus a tensor, first it will go and say, look at the 3's add dunder method and say, I don't know what to do with this. So then it'll fall back to this other one. And I'll just say this will return underscore add ensure tensor self, or no, other, and self. Okay. And now everywhere I used add, which I think I used it in subtract. Now let me just put that there for a minute. And I probably have to do it in my test as well. So test tensor add. So now two things. One, I'm just going to rewrite all these and say t1 plus t2. And similarly, I'll do T1 plus T2 because I basically gotten rid of that add function. I made it private and forcing you to call, T1 plus T2. Now I don't need to export it. And so we do PyTest. That worked, surprisingly. Okay, so I said there's one other thing I forgot to do, and that's as follows. I really should check that my addition, I checked that the addition was doing the right thing with respect to the gradients. I should have checked that it's actually doing the right thing overall as well. So, it would be bad if I implemented the gradients correctly, but I didn't implement addition correctly. So let's add a few asserts in here. T3.data.toList, and that should be, it's going to broadcast, so it's going to be 8, 10, 12, and then 11, 13, 15, and then I think that's going to be the same down here. And let's just run that test again, and that still works, so that's good. Okay, so we've cleaned up the add. Now let's clean up the multiply in the exact same way. So I'll replace the multiply with the underscore and multiply. And then I'll add a mul magic function, which is what gets called when you do, times. So then I just want to return underscore mul self, and then again ensure tensor other. I should probably add a test to make sure that it works when I multiply by, say, 3. And again, I can do rmul of self other tensor, and same thing, ensure tensor other, and it doesn't really matter what order I do these in, but let's do that like that, and then find my tensor mul, not import this anymore because it doesn't exist, and so let's call this T1 times T2. That's a much more natural times T2 and T1 times T2, and then again I'm going to add the tests that I should have put. Assert T3.data to list is, if I'm multiplying, that will be 4, 10, 18. And now assert T3.data to list. And again, I'm multiplying, so that will be 7, 16, 27. And 4 times 7 is 28. 5 times 8 is 40. 6 times 9 is 54. And then you can do the same thing here. And again, let's run the tests, and that passes. And, this is boring, but it's giving us a cleaner API, which is nice. So let's do underscore neg and underscore sub 2. And then once I do that, I can just do actually T1 plus minus T2, and that will work when I define the appropriate dunder methods. So, def neg self, and that's what happens when I just put a minus sign in front of something, and I can just do return underscore neg self. That's easy enough. Sub, self, and other, and that will give a tensor. And again, I can just return underscore sub of self and ensure tensor other. This is a lot of boilerplate, but it's going to, it just gives us a nicer library to use. So return sub of ensure tensor other self. This one actually does matter, the directions I do things in, and I should write tests for those as well, but probably not going to. So again, I'll replace this with T1 minus T2 and assert that T3.data to list is, so what happens if I do T1 minus T2? That would be minus 3, and minus 3. Okay, so T3 is, again, T1 minus T2 is how we write it now. Assert T3.data.toList equals. Okay, so that's going to be, first row is minus 6, minus 6, minus 6. And second row will be 4 minus 7 is minus 3. 5 minus 8 is minus 3. And 6 minus 9 is minus 3. So that's good too. And T1 minus T2. And let's add that test as well. And just run our PyTest again. And they all pass. So, and you know, now, you know, if I do autograd.tensor well, it's not letting me import anything. It's behaving poorly. But so I can't even get at those sub. I mean, I could. They start with underscores, but I can't really get at them. So I forced myself into this API. So now we can go back and clean up this. So I'll just say x times x dot sum. So it goes backwards. And now, in theory, I should be able to just do that. And I still have a problem here, but I think that will work. Can't import name mul, right? So I don't have that name anymore. Name grad is not defined because it's x.grad. And so it still works, you know, exactly the same, except now instead of having to call the mul function, I do x times x, and instead of having to do the really ugly thing I did before, I can just say delta x equals 0.1 times x.grad, which is nice. So I've taken something that's actually not a tensor, and I can multiply it by tensor, get a tensor, so that's good. This step is still nasty because we don't have these in-place operations yet. So let us go and add those. And those will be a little bit more interesting, and we'll see why. Okay, so, you know, when we do t plus equals other. So here, you know, the I is for in place, I think. So we want to do an in place add. So when I do an in place add, I want to actually replace the data. And then the other thing I want to do is I want to invalidate the gradient. So why is that? So, you know, if I say C equals A plus B, and then I do some kind of, well, that's maybe a bad example, but, you know, C equals some function of A, let's say. And then I compute, you know, the gradient of some function with respect to C, and I use my automatic differentiation to compute the gradient with respect to A. And that gradient going backwards depends on what f is, but it also potentially depends on the value of A. Like you saw that when I did the multiplication, how the gradient, you know, depended on the numbers themselves. So when I change sort of in place the value of A, that means that whatever gradient I've computed there is potentially wrong. So we're going to do a couple of things. So first we're going to say, you know, self.data plus equals, and other we want to ensure it's a tensor, say, other.data. So that's fine. And now we want to say that self.grad equals none. So invalidate the gradient. Okay. So basically, when we do this, we're saying you can't use this gradient anymore, and we're just going to do the same thing. So I can do an in-place subtract, and I'm just going to copy this because it's I sub. When we do t minus equals other, so now self data equals minus equals, and I can also do an in-place multiplication, and that's when we do t times equals others, self data times equals validate the gradient. Okay, so I should probably write tests for these. I'm thinking about that. But in the meantime, I can now say x minus equal delta x. And now I've done a couple of things. Is that before I was defining a new tensor each time, and because I define a new tensor each time, it started off with a zero gradient. Now it's not going to, and so I am going to need to manually call. I could do it at the end of the loop. The beginning of the loop doesn't really matter, but I'm going to say zero out the gradient. Now compute the sum of squares. Do backpropagation to compute the gradient now. Now adjust x, that will invalidate the gradient, and replace it with none, and then go back to the next part of the loop, set the gradient back to 0. So it's not none, now it's 0. When I do backwards, it adds to that gradient, and should still work, and it does still work. So we have cleaned it up pretty good. And I think that's probably all I want to do for now, unless I want to write some in-place tests. So maybe I want to write some in-place tests. So let me just do one at least. And so the thing I would like to do is say t1 plus equals 5, or say 0.1, okay? And so once I do that, a couple things should happen. One is that t1.grad should be set to none, And the second thing is that I have modified it in place. So now it's 1.1, 2.1, 3.1. And so let's run PyTest again. I think that will, nope, cannot cast ufunc output. Okay, so this is the same thing I ran into the other day. That's fine. I just need to equals self.data plus. So NumPy does not like the in-place operations. So I'm just going to rewrite them as not in-place operations. None type has no attribute grad. Okay, good. I'm glad I'm running these tests. IAdd is supposed to return self. Otherwise, it's not doing the right thing. Which makes me wonder how my in-place thing worked, but that's interesting. Okay, good. So once again, writing tests kind of saved our butt, which is a valuable thing to remember. Hopefully I'll remember it. Hopefully you'll remember it. And let me add an in-place test to each of these as well. Test tensor sub. I should probably write a separate test for this, but I'm lazy, so I won't. This will be 0.9, 1.9, 2.9. And then let's go to test tensor multiplication and add this test as well, t times equals. And now if I multiply by 1, it should be 0.1, 0.2, and 0.3. And let's run PyTest again. And something failed. And okay, it's my nemesis floating point thing. So we can deal with this. Pi as np. Np dot array there's something I can do. Maybe it's numpy.testing. Let's see. I'll figure this out. Assert array almost equal t1.data, and we'll see if it lets me get away with using a list here. Because the problem here is like a floating point thing where if I do 0.1 times 1, well that one's fine, but if I do 0.2 times 1, it's not actually equal to 0.2, which is, okay, good. So if I do numpy testing assert array almost equal, then I can, it's close enough. So in an ideal world, I would move all of these tensor sum and add and mul and everything over to a different module. The challenge is that I'm going to get a circular import, right? So so it just gets ugly. Because, you know, each of these functions depends on tensor, and then tensor's implementations depends on each of these functions. So I'd have to, you know, do an import inside the class, which not sure why not. So why don't I call this tensor ops.py. So just to clean this all up, I'm just going to take all of these functions and stick them in tensor ops, and now we're going to tensor import tensor. That's fine, and then probably I need, you know, port numpy as np, and what else do I need? I need list and dependency. And this is going to end up being more trouble than it's worth, but we'll do it anyway. From typing import list, Autograd tensor import dependency. And now what I will do is, and this is ugly, but you know, to avoid circular imports. And so how does this avoid circular imports? From autograd.tensoropts import add mul neg sub tensor sum, and that's, I guess I should call that tensor sum. And where is sum? Okay, so let's see what I broke. So I must have broken something. From Autograd Tensor, import error, cannot import name Tensor. All right, well, I already regret doing this, so I'm just going to undo it. Circular references are a real pain in the ass, so I'm not going to. So I'm just going to leave it like this, and I will think about a better way to handle this piece. And now let me try running PyTest again. See if I fixed my stuff. I did. Just for fun, let's do MyPy. It's going to complain about some stuff, I bet. Use the item none of optional tensor has no attribute data. Tensor 102. Add data. Grad is none. It's complaining because grad could be none, but I know that that can't be the case, so I'm just going to say type ignore, which is bad, but it causes things to pass. All right. So now we're in pretty good shape. If we go to minimize a function, now we can do tensors x times x and 0.1 times x and minus equals. And so again, I said this in the last video, but I'll say it again. The nice thing compared to the building a neural network library is that really constricted you to working with the layers, and each layer you had to implement the backwards function. Here we're down to these basic arithmetic operations, sums and pluses and times and minuses. And you can see that we wrote this in mostly a natural way. It would be nice if, we could use the sum function, but it's fine. I think it's okay. So anyway, I'm going to stop from here, and I think next time I have a few more pieces I need to do before I can actually do the capstone, neural network exercise. But I think there's probably two more videos before I'm done. So thanks for watching. Get add Autograd, get add minimize function, get add tests. Let's make sure minimize function still works. It does. Get status, get commit m part 4, and get push origin part 4. Okay, good. And it's all up on GitHub. So at Joel Grus, that's me, and hopefully I didn't do too much work in the part of the screen that's covered. So I will see you next time.